what happens with angles and arcs is that you're still going to use the same properties of things that you have done in the past. And you're just going to put them on a circle, really, and how these things work themselves through. So what I need to define with you guys, first of all, is a couple of things before we get into it. I just start to feel really bad. Look at me, I had a heart for a second. It's not ice going through my veins. A couple things I want to define. An arc. No, it's not a big ship. I get it. I'm sorry. I'm really sorry. I just don't have many. I don't really have good jokes.
Mr. Murphy, you just gotta work it.
Two guys walked into a bar, the third one ducks.
I get it.
Oh, I get it.
I don't get it.
What that mean?
Three guys walked into a bar.
The window would go down.
Two guys walked into a bar.
He's like, I'm not gonna say it. So
Like an actual
I was like,
Mr. Murphy.
The fact that he's going, I don't get it, then I go like this. And he goes, oh, I get it now.
Mr. Murphy, wait, ready? Okay, I'm gonna say knock knock. Knock knock.
Who's there?
You.
You who?
I'll show you this.
Let me see.
It's the guy from Frozen.
Yoo-hoo, big summer blowout.
Yeah.
That's great. I don't know why that's so funny, but that's really funny. That's good. That's really good.
Mr. Murphy, what is your preference for color?
It's green.
Does it mean no? Or is it like barley or like
Camouflage.
You got
forest green.
Green. Anyway, arc. An arc. An arc is the, it's the, how do I want to write this? It's the curve of a circle. And you probably knew that as you start to think of it. You think about an arc, or like the St. Louis Arch is a curve. A parabolas are curves. They have an arc to them. If you, really anything you throw, what goes up must come down. It's going to have some sort of an arc to it, things like that. It's, as we look at it in terms of a circle, an arc is defined by points on a circle.
So right.
There, well, I'm going to redo this here. So this A, B, let's see. What I would say is that the arc that I'm looking at here would be arc AC. You know how when we said segments, you put a little bar over it to tell that it was a segment. If it was a line, you'd have arrows over it. If it was a ray, it would be one. Yeah, it's just an arc. So this would be arc AC. It would just be, it would look like that. It's got a curvy hat. All right.
that's how we would write it.
What's that?
You say that's how we would write it.
Yep. That stands for arc AC, and that's that portion on the circle. This part here. And what we're going to do over the course of the next few days is talk about what are called arc measurements and arc lengths. They're two different animals, okay? You have arc measure, which we're going to look at today, and arc length we'll start with maybe Monday if we get through all this, which usually shouldn't be too much of a hassle. This portion that we're talking about today, the arc measure, is a lot easier. All right?
When are we
Excuse me, next
Today.
Thursday.
I have a question.
Yes, ma'am.
Today.
Thursday.
Right now.
Would that still be considered a triangle because it's curved or no?
No, this is, since this portion, that like that wedge piece with that curve, it's actually called a sector.
Okay.
And we'll talk about how you do work with those things later on.
All right.
Yes, sir.
Alright, so would it still be an angle that's going to occur at BAC?
At angle at BAC, so you're talking about, is there an angle here?
Yeah.
we don't worry about measuring the angle from a linear perspective to a curvature. We don't worry about that kind of angle measurements. Our angle measurements are going to be central angles, which is the angle at the center, or the degree measure of the curve. Okay, that's what we're going to worry about. Another quick thing to talk about on a circle is what are called degrees, and you know this. How many degrees does it take to go all the way around something? Okay, we knew that. So a circle in and of itself is built up of 360 degrees. Okay, so it's 360 degrees to go around a circle. What would a semicircle have? 180. Now, a semicircle, if you remember, we talked about this yesterday. A semicircle was made by what? What was that called? The diameter. Yeah. A diameter creates a semicircle. So a semicircle is created by a diameter. Okay? So a semicircle is going to be created by a diameter. It's half of a circle. And the reason that we talk about that is because when you have half a circle, you're going to know specific degree values then. Okay? We're going to know how these things intertwine to each other. That's the basics of where we're heading to today. The next chunk is talking about how these arcs are created. Well, they have to be created by what are called central angles. Where do you think a central angle might just be located in a circle? Ding, 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 ding. All right, so that's the next one. Are we okay on this right now?
Yes.
All right. A central angle. A central angle is an angle in a circle whose vertex is the center. And what do you think the sides of the angle are made up of? You said it earlier. Radius. The sides are just the radius. So a central angle is an angle whose vertex is at the center, and the sides are just the radius. Radii, you know the plural of radius? I think I said that yesterday, right? So central angle, angle at the center, vertex is at the center, the sides are radii. Now, that angle therefore has what are called endpoints on the circle. So this idea of this central angle it runs into an arc. The central angle, it runs into what's called its intercepted arc. So if I call this circle A, and this is B and C, I'd say that angle BAC intercepts arc BC. At point A is the center, BC are the endpoints, and that's what creates the arc. Okay? Now, the big thing about all these things, when we start talking about this idea of degree measures and what everything's going to measure, is that the measure of your arc, what we call the arc, the arc measure equals the central angle. So if your central angle measures 73 degrees, what is the arc that it runs into measuring?
A.
73 degrees.
Oh.
That's all that means. Angles and arcs. If an angle is the central angle, its arc measures exactly the same. So if you start thinking about if this was 100 degrees, that means that the measure of the arc is also 100 degrees. Okay? And if you think about it, if you start at, I'm going to put this in terms of an Algebra 2 thought. My Algebra 2 class right now, we're starting with what's called the unit circle. The unit circle is a trigonometric thing. You start at 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees, to go all the way around something, okay? So if I'm going just portion of it, this is just part of a circle. So if I'm going around something, and my angle comes around to here, and let's say this angle is 310 degrees, how much is left to fill that gap? 50. Okay. It's the same basic principle. You're going to do some adding and subtracting between 360 and whatever your angles are to figure out missing spots and so on. Okay.
You show us like a complex algebra problem with that. So I know that's not how simple it is.
Not right now. I'll get you. Let me get through some of these definitions. If we have a little bit of time, I'll show you something. I'll show you what we're doing right now. Now, that also allows us to define two other things. A minor arc and a major arc, exactly. So you get what are called minor and major arcs, and I want you to think of these as big arc, small arc. Think of it as acute and obtuse.
Bigger than 90, smaller than 90.
Kinda, but what's the delineation line in a circle, do you think?
I'm going to take a wild guess. 75.
Nope.
90.
Nope.
180.
There you go. Third time's a charm. Basically what you're looking at here is if you get to 180 degrees, you're half a circle. If you're less than 180, you're what you called a minor arc. If you're more than 180, you're called a major arc. That's all that means.
So just more than 50%.
Yeah.
Covered, yeah.
So a minor arc is an arc that is less than 180 degrees. I'm just going to do that. A major, I don't want to say acute because it could be 110 degrees. And that would be an obtuse angle, but it's a minor arc.
Wow.
Okay. So a major arc is an arc whose measure is greater than 180. Oops, I'm sorry. Let me write this backwards. It's greater than 180, but smaller than 360. We don't worry about angles that go around more than once.
Wait, so angles under?
Under 360, but less than 180, or but greater than 180.
Wait, repeat, no, minor.
Minor is less than 180.
Oh.
Wait.
Because if it equals 180, it's neither. It's called a semicircle. What's up?
If it's like, and then it's like, so it's like A, C, B, but it was like that,
Uh-huh.
then couldn't it be both? Like, couldn't this be a major arc and this be a minor arc?
I like where you're thinking because there's a specific rule that has to occur.
Okay.
You're on the right track. Now, when you are a minor arc, you are generally going to be 2 letters. 2 letters, and this is where you're going with that, Kevin. 2 letters always will show that it's the shortest distance between 2 points. Because you're right, if I say arc AC, I don't know if I'm going short or the long way around.
Right.
So whenever you see 2 letters, it means that it's implied that it is a minor arc. There are sometimes, you can get extra letters thrown in there, but more often than not, the letters tell you direction. Minor arcs will have 2 letters. A major arc in what you were saying, if I throw a D here, would be a DC. Because it's telling me to start at A
Like
and work my way around. Okay? There will be times that within a minor arc, there could be an extra segment, and this could have been E, and it could have said arc AEC, but it's still telling you to get to this point. It's telling you the direction to go. Just like segments do, just like angles do. Arcs, the lettering of arcs tell you the direction that you're going. That's a great question. Does that make sense? Now remember, if your arc measures 180, what is it? Semicircle. Yes, ma'am.
Will there ever be like something where it's like arc AE plus arc EC?
Arc what?
E.
AE? Yeah. That just means you're looking at whatever this is.
Plus EC.
Yes.
AE.
Yes. Because angle addition is nothing more than arc addition. And that's exactly where this comes to. Because if you look at angles, if you're adding two angles together, if I take two angles, let's say this is 62 degrees and this is 44 degrees. If I look at that and I wanted to add two angles together, do they share the same vertex? Do they share a common side? When they do that, that means you can add two angles together. Well, what do you think changes when you put a circle in it?
Nothing.
Absolutely nothing.
Absolutely.
Nothing changes when you put a circle into it. You do the exact same thing. So this idea of what's called arc addition, as long as the arcs are created by, as long as the arcs are created by, they have that common side, the common point between the two, you just add them together. Yes, sir.
So for like, I'm not trying to get too ahead, but for like, if there's a question saying, because that whole thing's angle B, I would have to say just 60.
And arc AC.
Yeah, arc AC.
Okay. Arc AC. What did arc AC has to equal?
Well, 62, but I'm saying
Okay.
like
What does arc CD have to equal?
44, but I'm saying, never mind.
So bad.
What if you have to find arc AC? That's what I'm saying.
You'd have to know some information, and we're gonna get
So
there.
you can't do like, where it says 62, you can't do like x plus something, and then up there say x plus something, then you equal to each other, then you can get.
Not yet. We're not gonna get. Eventually, we'll get to some algebra stuff. Today, it's just a lot of fill in the blanks. Okay. What would that be? What would that be? Arc AC.
106.
106. Everybody okay with that?
This is kind of easy.
Okay.
It's hard.
Don't
Yeah,
say
I was
it.
gonna say.
What is this?
A,
Going the other way around.
one or
What do you do?
set or
What are you doing?
Oh, I know. You just take out from 360, yeah. 106. 360.
Yeah, that's it. Because we know, guys, we know that there's a finite number of degrees in a circle. What I mean by that is there's always going to be the same amount of degrees in a circle. It's always 360. If you know that this chunk is 106 of them, what's left to get you around the rest of it?
250.
254. That's the idea of what we're doing today. It's going to be pretty simple math to make it work. Okay?
Yes.
So far, so good?
Yeah.
homework?
Homework. Let me give you another example.
180.
No.
Now this is kind of how things would be worded, where they're going to give you an angle, and it'll say that one of the segments in the circle would be a diameter, and you'll see that you're going to get more and more and more of these big picture style problems with circles, especially because you can start picking and choosing pieces to find. And each day as we get into this, we'll add a little bit of algebra, we'll add into what's called arc length. That's like the perimeter of a circle versus the angle measurement of the circle. Yes, sir? We'll get to chords eventually because there are rules about when chords intersect arcs, and depends if the chord hits a tangent line. There are different rules for everything. There's about 6 different rules, but they're very long worded formulas and theorems. I make it so that it's outside times the inside. You know, I word it so that way it makes sense. At least I try to. So you've got that angle LJM. Is that that means that arc LM is it a major or a minor arc? It's minor because the angle is less than, right. It's less than 180. So that means that what's the arc measure then of LM?
125.
125. Good. Everybody okay with that?
Yes.
All right. Because remember, arcs equal their central angles. Now, what would then be to go from L, M,
305.
Yeah, that's what I got too.
because we know there's 2 ways to do this.
235.
This part is 180. Everybody okay with that?
Yeah.
Now, how many degrees is it to go all the way around? 360. So 125 in this gives you 305. Or, what's the supplement to 125? Can't you take 360, subtract 55? It works the exact same way. There's more than one way to do this.
And then the last one is.
What's wrong? No, go ahead, say it.
This better be the easiest it gets. Or the hardest, I think she meant.
Yeah, the hardest.
It gets there, but don't freak out yet. What about KLM?
180.
180, because KM are endpoints of a diameter of a semicircle, all right? All right. I think I have one more for you. That's a 70. All right, last one, then we'll do this and I'll give you some problems.
I see a 90, I see a 30, I see
Let me write that.
What's the missing angle real quick, guys?
60.
60.
Wow, you're so good, girl.
Good job, Tori.
Go Toros.
Arc. The herald angels sing.
Glory to the newborn King.
AD.
That's my favorite Christmas song.
I can answer all of them.
AB.
60.
Wait.
CD.
230, I think. That's what I got.
180.
Oh,
That's
my bad.
1057.
CD.
You mean AB?
BDC.
That's what I got. Oh my gosh, you guys are so
Just working the 310. Remember, the lettering tells you the direction to go around the circle. So you start at B and you're working your way back up and around. Okay. A, C, D. 290. Good. You go take your 360. Take your 360 and subtract out the 70. You have 290. And last but not least, 50. Yeah.
So wait, hold on. When you give us the homework, it's gonna look like this.
No.
Cause sometimes you be like,
What?
that's fine.
Oh, yeah, that's right. I'm sure that's what he
What's good about it?
said. So,
Oh, shit.
on this one here, guys,
God, dominoes.
All right, we'll go through those. Monday we'll get into this. We'll throw a little bit more of the algebra into this on Monday, and then go from there. Read the comments.
I got it.
Was there enough of them, or was this just straight around? I may or may not have counted correctly.
Like Randy
It's a scary thought.
because he was fucking buddy.
They didn't tell me I had to count anything. They just had to know how to present stuff sometimes.
It's out west 290.
This is too hard.
Quit your complaining. Okay.